Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing systems of equations. This is standard A.2I in the great state of Texas, and we are using item number 39 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got line N on the coordinate grid. We got some ordered pairs here on line P. We need to find a system of equations that best represents line N and P, right? And so let's do this. Let's go ahead and we're going to scroll this down here so we can see our answer choices. And let's just write what we know about these. All of these equations here are going to be in standard form. So what I'm wanting to do is I'm going to write them in our slope-intercept form, and then we're going to have to convert them over, right? So how do we find some of these things? Well, I mentioned several things. We've got our standard form that's ax, right, plus by. So let's put that here. That's what it needs to be, equals c. Now, our slope-intercept form is what I'm wanting to get them to first, because we can identify the slope and the y-intercept from our points. And we know that if we think down here, our slope of a line is going to be the change in y over the change in x. All right, so let's first find the slope of these lines. And let's start with, I've got my 2 points here. So let's call this x sub 1, and this is y sub 1. We'll make this x sub 2 and y sub 2. You could flip those and you'll still get the same exact slope. It doesn't really matter. So let's say my y sub 2 is going to be negative 2 minus my y sub 1 is 1, and then my x sub 2 is 0, my x sub 1 is 1. So that gets me negative 3 over negative 1, and so I'm going to end up getting a slope of 3. Also, what I could have done is rather than calculating that, I could have just done my rise over run, and I could have gone up 1, 2, 3, and then over 1, and that's a positive 3, positive 1. Okay, so my m for this first one equals 3. Now, if I needed to, I could plug in one of these points into my y equals mx plus b, solve for b, but I know that my b is my y-intercept, and they give it to me. It's right there. So my y-intercept is what happens when x is 0. Where does it cross? Crosses at negative 2. So my b equals negative 2. So then I can say this first one is going to be y equals, my m is 3, and it's going to be end up being a plus negative 2, or I can just do minus 2. Now, if I want to change that into my standard form, right, I need to get my x over here on my left, right? So I can subtract 3x from both sides. So negative 3x plus y equals negative 2, and we're not going to have a leading negative, so multiply everything by negative 1 and just flip the signs, right? So that's going to end up being 3x minus y equals 2. All right, so we're down with that one. Let's see what we have over here. I'm going to take 2 points. Let's just take these two right here. Y sub 1, y sub 2, x sub 1, x sub 2. You could take any 2 points as long as the x sub 1 is across from the y sub 1, and so on and so forth. So my m is going to be 2 minus 4. That's y sub 2 minus y sub 1, and then 1 minus 0. So negative 2 over 1, or negative 2. All right, so y equals, my m is negative 2x. Once again, I could plug these numbers in, but if I've got an x of 0, then that right there is my b. There's no need to calculate that. And it's going to be a 4. Negative 2x plus 4, same thing. Let's get that x over here, add 2x to both sides. My 2x is positive, so we're good there. Plus y equals 4. So now I've got these two statements here. I've got my 3x minus y equals 2, 2x plus y equals 4, and hopefully you see that we've got that right here on A. And if we wanted to, we could actually plot this line, find the intersection point. That would be the solution to both. And if we wanted to double check, we could put that x and y coordinate into both to make them true. But our answer here is A.